Welcome back to Quick Look on Solid Phase Extraction. In the third and final part of the series, we conclude our discussion on SPE and the long-standing dispute amongst the SPE community, vacuum or positive pressure. With me, I have three SPE experts who will continue to help us answer this question and finally get down to the bottom of it. Welcome back, Melvin Blaze.
Hi.
Ken Berthollet. And Katie Brennan. We've talked a lot about the differences between positive pressure and vacuum. Melvin, do you find any similarities between the two?
Yes, both are used for SPE. So there's a lot of similarities in terms of getting your analyte extracted from the sample that you want. Both does the job that you need. But in terms of improving the reproducibility and recovery, there are some subtle differences that I feel there are between the vacuum manifold and the positive pressure manifold.
Do you find that it is easy to transfer methods from vacuum to positive pressure or vice versa?
It's pretty much, I would say it's very difficult to transfer the exact method because one is based on vacuum. You use vacuum to run the vacuum manifold. For positive pressure, you use nitrogen flow through the cartridge. So you cannot use the exact same settings because they are totally two different instruments. So however, you need to optimize separately for both the vacuum manifold and again for the positive pressure manifold if you have to transfer the methods from one manifold to the other. So it's not easy overall.
If I can just add in another similarity too, is they're both very manual. So if you have someone who's a novice user, maybe right out of undergraduate school and they're hired just to run samples, they have to have a significant amount of training to use these devices, which it's definitely a bad thing, but it's the same on both positive pressure and a vacuum manifold. Just another thing I've noticed.
Absolutely. So you find that an individual's technique could have a fairly severe impact on the success of the method.
Mm-hmm. Yeah, especially if they don't control the flow, as we talked about in a previous episode of this.
Yeah, that's probably one of the biggest differences, I'd say, between a positive pressure manifold and a vacuum manifold. The pressure.
Because one's positive and one's negative.
That's right, Paula. Well, also, and with vacuum, it's not an even flow across all the wells. It's pulling at wells and as a whole. So you could have one well that's clogged and it's going to pull harder on every other well as well. And then on the positive pressure side, you are always going to have even pressure in every single well, no matter if they're viscous samples or not viscous.
Right. The pressure is going to choose the path of least resistance, right?
Definitely.
Do you think there's anything that can be done to mitigate this risk?
Yeah, there could be. With more viscous samples, there could be some sample pretreatment steps that you have to do prior to applying pressure to make sure that at least for vacuum, all of your samples are being pulled through in a more similar way.
Yep. And I think if you're looking at transferring method from one user to another user, if you have some way to program and save the method that one creates versus the other, then if the other person wants to use it, then they could do that. But there are no options available with the current manifolds that we have in the market right now. So I think that would be a good thing to have, manifolds.
I know with some of the methods I've had to make, we've actually written down in the procedure, you're going to turn off and on the pressure this many times with this long of a pause in between, just to really make sure that it's being very well controlled, regardless of who's doing it.
Yep. That's why you guys are the analytical experts.
And the worst is when you forget a step, huh?
Yes.
You can't walk away from it.
So other than keeping track of where you are in the protocol, do you have any final recommendations for our customers to make sure that they are processing their SPE to the best of their abilities? You guys are all forgetting one very crucial step.
What is it, Paula? What are you holding back from us?
Don't forget to change out your waste collection for sample collection.
Of course.
I have been burned by that far too many times.
Oh,
And
same.
clearly we
Yes.
need the reminder. We needed the reminder.
Right?
Yeah.
I wish I had someone next to me all the time saying, "Hey, you got to go and change out your plate, or you'll lose everything."
Oh, and that first drop of the elution is like the most crucial piece.
It is. It really is.
It's heartbreaking once it goes into waste.
It's happened to all of us.
It has one too many times.
And sometimes you forget to which step are you in. Like since SPE involves so many steps. Oh, did I complete wash 1 step versus wash 2? So yeah.
Been there
Yeah.
too, for sure.
A couple samples might get an extra wash here and there. So I guess there's only one way to close out the discussion. I'd like each of you to let me know what your preference is, vacuum or positive pressure.
I
Oh,
vote for
hands
positive.
down. Positive pressure for sure.
I would love to use positive pressure for everything, but there are some applications where I just can't. So,
Oh, Kenny,
That's-
always looking at the negative.
well, it's true.
Well, he is because he's using vacuum.
Right. If I have to use those large cartridges, we don't have a positive pressure manifold that works. So I'm forced to use vacuum manifold. I would love to use positive pressure for everything,
True.
but I can't.
So positive
Yeah.
pressure where applicable.
Yes.
All right. Well, that wraps up part 3 of Quick Look series on solid phase extraction. Thank you again. Thank you all for joining us. Thank you for joining us and sharing your SPE expertise. And to find out more information and different tools about processing SPE and what's to come, visit waters.com/auto.